Alright, in this video we're going to take a look at some application problems involving algebraic expressions. So let's do that through examples. Alright, in example 1 it says there are 25 students in a class. Express the number of male students relative to the number of female students in the class. So what I'd like to do is make a list, and we're going to put F for female and M for male. And it's just by the way the instructions are written here. They want us to express the number of male students relative to the number of female students. So I'm just going to let X represent the number of female students. And because the total number of students is given in the class here, what we do is we just let the male students be expressed as the total, which is 25, minus the number of female students. Now remember, when you add these together, the number of female students plus the number of male students, you need to come up with 25. So I'm showing you this to hope this helps you understand why it has to be 25 minus X. So we're saying here that the number of female students is X, and the number of male students is 25 minus X. Now what happens is the X for female is a positive, and the one for the male is negative. So those will cancel each other out, and it leaves you with 25 total students, as we need to have per the instructions. Now, you could have done this the other way. You could have let the male students be X, and then the female students could have been 25 minus X, like this. The key is, if the total's given, one of the items in the list has to be X, then the other one has to be the total minus X. Again, just by the way this problem was written, they want us to express the male in terms of the female students, so that's why I chose X for the female, or the number of female students in the class. All right, let's move on to example number 2. Number 2, a jet is traveling at a rate of 175 miles per hour, less than twice the rate of a propeller aircraft. Express the rate of the jet in terms of the propeller aircraft. So here again we have two things. We have the jet, and then we have the propeller aircraft. Now it says the jet is traveling at a rate that is 175 miles per hour, less than twice the rate of the propeller aircraft. So right now we know the least information about the propeller aircraft, so we're going to let that propeller aircraft be X. So what we now do is go back to the relationship. The rate of the jet is 175 miles per hour, less than twice the rate of the propeller aircraft. So how do you say 175 less than twice the propeller aircraft, which is X? Well, 175 less than, don't forget about the word then we'll change the order of the terms. So 175 less than 2x is written as 2x minus 175. So the instructions wanted to know, they wanted us to express the rate of the jet in terms of the propeller aircraft, so the answer would be 2x minus 175. All right, let's take a look at example number 3. In number 3 it says the length of a rectangle is 3 more than 5 times its width. Express the length of the rectangle in terms of its width. A couple different things we can do here. We can create our list. We're talking about the length and the width of a rectangle. So again, this is called a list or a chart. At the with the first sentence, the one we know the least about is the width. So we're going to let X represent the width. So it says the length is, which means it's equal to, 3 more than 5 times the width. So how do we say 3 more than 5 times the width, which is X? Well, don't forget about the word than. What it does, it changes the order. We said 3 first when we read it, but in the algebraic expression it has to come second. So 3 more than 5 times the width would be 5x plus 3. Now you could have also drawn a picture of a rectangle, and it doesn't really have to be proportional, but this is just another technique you could use. We could let X be the width because we know the least about that from the first sentence. And then again it says the length is 3 more than 5 times the width. So how do we say 3 more than 5 times the width? Again, it's 5x plus 3. So a lot of times in application problems, the list is a nice method to use to help us express the items that they're discussing in the problem, but also just a picture or a diagram of the problem is also helpful. All right, so let's move on to example number 4. Now, number 4, there's a lot going on here. We're talking about several different things. So it says John is twice as old as Mike, Allison is 18 years younger than John, and Ty is 3 times older than Allison. Express the age of each person in terms of Mike's age. So let's just go ahead and write down the initials of each person. We're talking about John, we're talking about Mike, we're talking about Allison, and also Ty. Now, one of these individuals will be X, and it's the person that we know the least about. From the first sentence, it says John is twice as old as Mike. So far, we know the least about Mike, so Mike will be X. Well, John is twice as old as Mike, so how do you say twice as old as Mike, which Mike again is X? Twice as old as Mike would be 2X. Next, it says that Allison is 18 years younger than John. Let's stop there. Well, how old is John? John is 2X years old, so Allison is 18 years younger than John. Don't forget than is going to change the order. So how do you say 18 less than 2X? That's 2X minus 18. The last person we have to talk about or express is Ty, and he is 3 times older than Allison. Well, 3 times older than Allison. Well, how old is Allison? Allison is 2X minus 18 years old. So 3 times that would be 3 times the quantity of 2X minus 18. So we have expressed the age of each person, and hopefully this makes sense. But anyway, don't forget, making a list is an important skill to be able to have to help you solve application problems. But the purpose of this video is just really to kind of show you how to piece through or work through these word problems and express items algebraically. So I hope this helps.